All right, this is Mr. Barr, and this is rational versus irrational and estimating square roots. All right, so here's what we're going to do. There are a bunch of different types of numbers in the world. When you were young, you started with things like 1, 2, 3, 4. So some basic numbers, those are actually called the natural numbers. Then we went to 0, 1, 2, 3, 4. Those are the whole numbers. Then we started throwing in negatives, so things like -2, -1, 0, 1, 2, 3. These are the integers. Then we started throwing in the decimals, things like 1/2 and 0.5s and 1/3 and 0.3 repeatings. And all of these guys together form a number set called the rational numbers. So all of these numbers that you kind of grew up with are called the rational numbers. What we also have are a bunch of weird numbers that are called irrationals. So I come over here to my irrational numbers, and these are the numbers like pi. They're like the square root of 2, the square root of 5, the square root that I don't know. Like a non-perfect number, a non-perfect square. A square root of a non-perfect square. They're numbers that go on forever without repeating. So I've got rational numbers, which are the basic numbers, and then pi's and non-repeating decimals. So I need you to be able to identify rationals versus irrationals. So here's what you're looking for. If I see a pi or a square root that I don't know, which means a square root that is not a perfect square. So irrational is pi or a square root of a non-perfect square that's irrational, or a non-repeating non-terminating decimal. Irrational, so things like pi, square roots that I don't know, and non-repeating, non-terminating decimals. These are things that go on forever without repeating. These are irrational. So if you're looking for these, you look for these. If you see it, it's irrational. If you don't see it, it makes it rational. So here's some examples. I'm going to throw a number up here. I'm going to give you a couple different numbers, and you're going to tell me what's going on with it. So pi. What is pi? What is the square root of 8? How about 1/2? And how about -3? Pi, irrational. Square root of 8, irrational. This, well, the fact that it's not pi or a square root I don't know means it's rational and rational. Also, when I start multiplying things, 3 times pi, irrational, because that's irrational. 3 times the square root of 2, irrational. 3 times 8, rational. -3 times -8, rational. So as soon as I see a pi or a square root or some kind of a crazy decimal, something that goes on forever without repeating, that tells me that it is irrational. Irrational, irrational, irrational. If I don't see it, that means it's rational. Next, approximating square roots. So at this point, you should know a whole bunch of square roots. I'm just going to do up to like 5. The square root of 1, the square root of 4, the square root of 9, the square root of 16, and the square root of 25. What's the square root of 1? Well, it's 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. And the square root of 25 is 5. I call this the math neighborhood. I've got these houses and who comes out of those houses. Now, I want to estimate the square root of 16. No, I'm going to estimate the square root of 15. The square root of 15 would be somewhere right in here, right? Well, the square root of 15 is going to be somewhere between 3 and 4. Man, it's so close to 16. It's practically 16, right? There's 3.1, I've got 3.1, I've got 3.2, I've got 3.3, I've got 3.4, this is pretty much like what? About 3.9. That's an estimate for that square root. Well, let's put a number down here. How about, let's go over here. Let's do, I don't know, square root of 26. Square root of 26. Right? Well, that's somewhere between, right? It's between 5 and 6. And it's just a little bit bigger than 5. What's a little bit bigger than 5? Maybe about a 5.1. Let's come down here. Let's estimate the square root of, I don't know, square root of 7. 6, 7. Square root of 7. Square root of 7, well, it's somewhere in between 2 and 3, right? I don't know. Is it right in the middle? Well, 4, 5, 6, 7. That's 3. This is 2 away. I don't know. So it's a little bit closer to the 3 than it is to the 2. What would you call that? Maybe a 2.6? These are just estimates. So I need you to be able to estimate these also. All right, that's it. Thanks for watching.